Okay, sorry for interruption. Let me continue. So I need this AX here, the area of the cross section. So let's look at this more carefully. This is the point on the x-axis. The distance is x here. What I need is the radius. So this is a circle, right? So when you rotate, you go in a circle. So if I look at it this way, just a circle, like this. And this one will be a circle inside, like this. And the end is like this. So all of them are circles, and all of them have the same center, which is on the x-axis. So let's just look at this one from different view. So from here, I have this. This is point X. X here in fact. And radius, if you look carefully, the radius is in fact this. This is the radius. So the radius is in fact this. Right? R. So what is R? R, if this is X, this is the graph of Fx. R is Fx. R is Fx. So at point X, the radius of this cross section is Fx. So this will be area of a circle with, so this, if I draw this from this viewpoint, this is Fx. So I have a circle with radius Fx, and this is Ax. The area of this thing is Ax. So Ax is pi r squared, so which is pi times Fx squared dx. Okay, so volume of this object, this solid of revolution, is this. So the volume, which is integral of dv, is integral from a to b. In fact, x goes from a to b of pi Fx squared dx. Okay? So, that's it. That is simply area of volume of a solid of revolution. Is that simple. Now, so let me give you some examples here, and then we'll continue with volume. Okay, now examples. One, let's say we revolve the graph of Fx, square root of x, about the x-axis from x equals say 2 to x equals say 5. Okay. Well, it definitely looks like the thing that I had before. So from 2, because the function goes like this, so 5 say, and it should be something like this. Let me I usually draw the picture first and do this. So let me this should go like that. x from 2 to 5, and this, if we continue, this goes to 2.0. So that is a square root of x, and the volume of the solid of revolution by the formula, it is from 2 to 5 pi times square root of x squared dx. So that is pi is simply a constant, pi x dx. So that is pi times 1/2 x squared from 2 to 5. So that is 1/2 pi times 5 squared is 25, 2 squared is 4. So that is 21 pi over 2. Depending on the units on the x and y axis, that might be, I don't know, square feet, square inch or something. Anyway, that leave it to physics. So for us, that is the volume. It's that simple. Let's do another one. And now this time I revolve the same thing about the y-axis. From x equals, say, 4 to, say, 25, say. Okay, well, y-axis is very similar. Y-axis, if I revolve something about the y-axis, I have something like this. In fact, that gives us a much nicer picture. So let me draw the solid first. It's easier to draw solids like this than the other way. So this is like the y-axis. And the x-axis. And this is the curve. So that is x equals hy, right? And the volume will be something, let's say, from C to D, CD pi hy squared dy. So if it is revolving about the y-axis, then you have to have x in terms of y. So y is the independent variable. And the formula is similar to the formula for when you revolve it about the x-axis. So, in our situation, we have this curve, and we need the points on y-axis. So we have 4 and 25. 4, the square root of 4 is 2, and the square root of 25 is 5, right? What does it look like? Well, let me try it. It's in fact something like that. So let me graph something for you, so you have some feeling what it might look like. Something like that, right? So okay. So, well, I guess this should pass 2.0. Anyway, that's not such a big deal. So that it looks like this. Well, that's not the point. The point is simply what? Finding what do I need? I need this, this, and this. Okay, I have fx, which is y equals square root of x. Solving for x gives me x is y squared. So hy is in fact y squared. So that is the first step. Second step is finding the c and the d. With the c and the d, c is 2, that's square root of 4, and D is 5, square root of 25. Okay, I have everything, and I can find this volume. So let me erase something here, but I can write it here. I already have. So the volume will be integral from 2 to 5, 2 to 5, and pi times hy, which is y squared, square dy. So that is pi, that is y4, so that is 1/5 y5 from 2 to 5. So I have pi over 5 times 5 to the power 5 minus 2 to the power 5. Well, you can just leave it like that. If you need approximate value, you can raise it to power 5 and subtract, and you have the exact volume. But that's how you find it. How you calculate the volume of a solid of revolution which is revolved about the y-axis. Okay, so now what if we have something like a shell, which is, if I revolve, well, this is revolving an area, right? So the area can be area between two curves. In both cases, it was area which was limited to one of the axes, either x-axis or the y-axis. So that was area between graph of a function and the x-axis, or graph of a function and y-axis. Now, what if it is between two curves? How do you find volume? So let me draw a picture for you. So let me draw a picture first, then the axis for you. So this is one curve. It's not easy to draw straight lines on whiteboard. And this helps with the so say x-axis and say y-axis, and now we have some interesting notion here which comes in handy. So this is like the region between two curves. So what are the two curves? Let me erase this. So this is fx, and say this is gx, and it's a region between these two. You can see that this region is, you just imagine this goes round and it produces like a thickness, something like I don't know, like a glass. Well, a glass is something which has thickness. Okay, now we need the AX. Well, what is AX? AX, as I said, and it's the same thing, so I can start, if I start at 0, just go in distance of x, say, at least x, just find the intersection, the AX here. So what is the intersection at this x? At this x, the intersection, if I look at it this way, at this x, the intersection at this x, imagine it is something like this or like this, right? It's like this, except it might be smaller or larger, depends. So the intersection is like this. It's a washer, what we call a washer, right? It's like a washer. So the intersection at x, or the cross section at x, the cross section at x looks like this. Done. Okay. So I have two concentric circles, and AX is in fact this area of this thing. And what is the area of this? So I have one radius inside and one radius outside. We call this RO and this one RI. So RO is outside. Is that clear? Yeah, outside radius. And RI is inside. Inside radius. Okay? So what is the AX in fact? AX will be, this is at point X. AX, the area will be area of the outside circle, which is pi RO squared minus area of the inside one. So AX is in fact this. If this is AX, then the volume will be AX dx. So volume, which is integral from say A to B, whatever that is, AX dx will be integral from A to B, pi RO squared minus RI squared dx. Now what is RO and RI in this picture? RO is this, and RI is this. So what is RO at x? RO is f of x, right? But let me draw the picture here. So that's x, RO, RI. This is fx, this is gx. So the area will be, volume will be, let me write the volume in terms of fx and gx. So the volume will be this, from A to B, pi fx squared minus gx squared dx. Okay. So I hope this clarifies everything. The RO and RI are crucial in finding volume, in fact. Well, it becomes handy in other areas too. But now, this is when you revolve about the x-axis. But you can revolve about anything, any axis. Well, we are not going to revolve about an axis like this. So we only revolve about axes which are parallel to x-axis or y-axis. So in all cases, this is for when you are revolving about the x-axis. What if you revolve about y-axis? Y-axis will give me something like this: C, D, pi, again R O squared minus RI squared dy, right? And then this might be HY squared, and this might be KY squared, right? So that is the case when it is about y-axis. But I don't recommend memorizing. Well, you have take-home exams. So anyway, usually don't memorize, I just know this formula, that it is the outside radius squared minus the inside radius squared and the integral times pi. So if I revolve it about any other axis, if I can find Ri and Ro correctly, then I have the volume. So let's revolve this about axes which are parallel to one of them. So let me resolve these things. Well, maybe this is not a bad idea to just keep everything. So let's say my x-axis is does not pass through the center line of this. So this that connects the center of this one to the center of this one is called the center line. Now, say the x-axis might be here, and this is revolving about a line which is parallel to the x-axis. So let's say it's revolving about line let's say this point is 5. Y equals 5. Okay? So it's revolving about point y equals 5. So what should I find? Well, let me draw the picture here. So the flat is like this, say, and y equals 5 is here, and I have two graphs. Revolving about this. Okay, what do I need? The RO and RI, they start here at this axis of rotation. So RO and RI are calculated with respect to axis of rotation. So this will be RI and the other one RO. And the volume is the same. The volume of this object, if this goes from A to B, say A, B, so the volume is simply integral from A to B pi RO squared minus RI squared dx. So if you remember that it is RO squared minus RI squared, then you can find volume of any sort of revolution which revolves about any axis parallel to x or y axis. In this case, it is parallel to the x axis. Okay, let's see. What do we have here? What is given to us? So let me extend this thing to the x-axis. So this is x here, x. Right? This is what x. And from here to here is fx, right? And this is gx. So from here to here is fx, right? So what is Ri in terms of fx? It's fx minus 5, right? This is 5. So this 5, right? So this whole thing is fx minus 5. And you can guess in is also this is all. So and the Ri inside will be gx minus 5. Okay, I made a mistake. The other one is Ro, this one is Ri, and that's gx minus 5. So with the volume, just plug in these two and you have the volume. Okay, now let me do an example here for this one. Sometimes it's confusing for some students. After doing some problems, it becomes clear. So don't worry about this. And so let's say example. Let region omega be let omega be the region. No, so omega be the region enclosed by the graphs of f, say fx equals root of x and gx equals 1/2 root of x, revolve omega about y equals -4. Find the volume of the solid of revolution. Well, I should give x, and x should be between, say, 0 and, say, 5. Okay. So, well, I didn't give that. So, what is the picture? It's this. I'm not going to draw the solid of revolution. Well, I might. So, let's see. So, if this is 0.5, I have this, and then this, 5, and this is y at -4. Okay. So, RO, I just need RO and RI, right? So, RO and RI, they are calculated with respect to the axis of rotation. This is axis of rotation. So, this is my RO, the outside radius, and this is RI. Okay? This is, in fact, we are dealing with distances, right? So, this is 4 as distance. Distance is 4. Yeah, that is at level -4, but as a distance, it is 4, say, centimeters, whatever that is. And this is fx, so the top one is square root of x, and the bottom one is 1/2 square root of x. So from here to here is square root of x, from here to here is 1/2 square root of x. Therefore, RO will be square root of x plus 4, and RI will be 1/2 plus 4. Okay? So the RO and RI are these two. So let's erase this part and find volume. Volume is then integral from 0 to 5 pi RO minus RI (0, 5) and pi is here, Square this thing, it is square root of x squared is x 2 times this plus 8 square root of x plus 16 minus. This one will be 1/4 x. Twice this times this will be 4x, or 4 square root of x, sorry. And 4 squared is plus 16 dx. Don't integrate. First simplify the integrand, then integrate. Please, please, please. I have seen students integrating this separately and then subtracting. No. Simplify before doing that. So the inside I have 0, 5, pi. I have an x minus 1/4 x, so that goes for this one. I have 8 square root of x minus 4 square root of x, and 16 minus 16. You see the 16 and 16 cancel out. So it is 0, 5, pi, and that is 3/4 x. This one is plus 4 x to the power of 1/2, that is square root of x. And that's it. The 16 and 16 cancel out. So it is pi outside, that is 3/8 x squared plus 4 times 1/1 plus 1/2 x 1 plus 1/2, and this goes from 0 to 5. Okay, so this is 2/3. 2/3 times this, that's 8/3. So this is 8/3. This whole thing is 8/3, and this is x to the power 3/2. And that's it. So you can now find this thing, and you do it. Okay. Okay, so that is a nice example. So don't go for general formulas. Just look at the picture, and from the geometry, find RO and RI. Because I have seen students memorizing, say, okay, Ri is, say, fx plus, say, something if it is above the x-axis, minus something if it is below the x-axis, and things like that. No, just look at the picture, and from information you have, find RO and RI. And don't forget, this RO and RI are related to the fx and gx. Only if it is revolved about the x-axis, they are fx and gx. Otherwise, they are fx, gx, plus or minus some number. Or if it's revolving about the y-axis or an axis parallel to y-axis, then again you have to add that or subtract, depending on where that axis is. So I'm not done with this volume, so I will continue volume next time. So see you next time.